everyone, this is Chetan Singhal. Welcome to my channel Stat Shine, where knowledge shines to make you shine. In this video, we'll be learning about Boxplot. In my earlier videos, I have explained about quartiles. So if you have not seen that video, please check out the link below and see that, because we'll be using these quartiles definition to explain how to create box plots, right? So firstly, we'll understand what is 5-point summary, right? So this is nothing but it consists of minimum, Q1 first quartile, Q2 second quartile, Q3 third quartile, and maximum. So given any data set, we can calculate these quantities, right? Q2 is nothing but the median only. So median is the value that divides the data set into two equal halves. 50% of the observations are to the left of it and 50% of the observations are to the right of it. And Q1 is nothing but first quartile, which means that 25% of the observations are to the left of it, right? And Q3 is a third quartile. So these are the quartiles, 3 quartiles, which divides the data set into 4 parts. So this is Q1, this is Q2, this is Q3, right? So this is 25% of the data, here 25%, here 25%, and here 25%, right? So what is box plot? So the way we create is box plot is something like that. So this is minimum value, right? We go till the point Q1, then we'll create a box and mark the median, and then we'll go till maximum. So this is minimum value, this is Q1, this is Q2, this is Q3, and this is max, right? So this is a box, that's why this is known as a box plot, right? So the length of this box is Q3 minus Q1, and this is nothing but interquartile range, IQR, interquartile range, IQR. Now we'll see how to calculate the outliers. So there is a fixed method to calculate the outliers. So we have calculated these quantities Q1, Q2, and Q3, right? So we'll calculate this Q1 minus 1.5 into IQR, where IQR is interquartile range, Q3 minus Q1, and Q3 plus 1.5 into IQR. So we'll calculate this thing. So if any of the observation is, so suppose this is Q1 minus 1.5 IQR, this Q3 plus 1.5 into IQR. So if any observations is out of these bounds, so if any observation is greater than this value, Q3 plus 1.5 into IQR, and if any value is less than this value, then it turns out to be outlier. Then we define that observation to be outlier, right? So this we call as lower fence, and this we call as upper fence. Sometimes this 1.5 factor is used as 3 in case of extreme outliers. Sometimes if we want to see if there are any extreme outliers or not, then we calculate this 1.5 into IQR as 3 into IQR, right? And these outliers, when we use 1.5, so these are, we refer to as moderate outliers or mild outliers. So this is the way we calculate the outliers. So this is one version of a box plot. What does the another version states? So we have calculated minimum and maximum over here, or plotted. So in that case, we'll plot something like this. So this is Q1, Q2, Q3. This is our lower fence. This is our upper fence, which is nothing but Q3 plus 1.5 into IQR, and this is nothing but Q1 minus 1.5 into IQR. And suppose if any outlier is there, we'll just mark it as a star. So this is another version of a box plot in which we just don't take the minimum or maximum. We'll just take the lower fence and upper fence, and we'll plot any observation as a star, which represents that this data set has an outlier or outliers, right? So this is box plot. So this is the median, and this is Q3 and Q1, and these lines are sometimes known as whisker, just a terminology, whisker, and hence it is also known as box and whisker plot, right? This is also known as box and whisker plot. So why this box plot is important and what does it help us to analyze? Now we'll see that. So here I have 3 different box plots, right, with the boxes being different. So we'll try to explain what does each box plot tries to represent, right? So this is Q1, Q2 and Q3. So if we see here the distribution of the data, so this is 25% of the data, this is 25%, this is 25%, this is 25%. So if I see, this seems to be symmetrical in nature, right? So this distribution of the data seems to be symmetrical. So somewhat if I draw a curve or a histogram to represent this, this would be something like this. This is our data, this is our frequency, right? Or suppose if I want to draw a histogram, so it would be something like this, a symmetric one, right? So this seems to be symmetrical because each of this 25% of the data is same, right? If you see this bin, this box plot, the second one, so this is 25%, right? This is Q1, Q2, Q3, and this is our maximum, right? So this is 25%, this is 25%, and this is 25%. So the amount of the data remains the same in each of these regions. So in each of this region, there is only 25% of the data. But you see after Q2, so Q2 and Q3 to max, the amount of data remains 25% only, but there is more scatterness in the data. So some sort of skewness is there, right? So if I want to draw a graph, it would be just like that. Some observations are outliers, right? These observations, they tend to be outliers as an unusual observations from our data set. So there are some observations over here. So in my earlier videos when I described about skewness, so this is a case of a positive skew or a right skew, right? Right skew because there are some observations which are outliers on the right side of the data, on the higher end of the data, right? And in the similar way, if we see this, so this is just the opposite case. This is Q1, Q2, Q3, this is max and this is min. So there are some outliers here in this region, moreover at this part. So here also it's 25% data, 25. So the number of observations in each region remains the same, right? but there are some outliers, more outliers present over here as compared to here. So if I just want to draw a graph, so it would be like this, right? From the plot also I can see this is something like it is, right? It is something like this. So this is nothing but the case of a left skew or negative skew, because the observations are to, some outliers are there to the left of the data or to the negative side of the data, which will decrease the mean, right? We discussed all these things in the skewness video, right? So if you haven't seen that, please check that out. So boxplot is the graphical representation, right, which help us to depict the skewness of the data and the distribution also. Skewness plus distribution, that how the data is distributed. So as a rule in the box, we say that if Q2 minus Q1, this part, and Q3 minus Q2, this part. So if Q3 minus Q2 is greater than Q2 minus Q1, then it tends to be positive skew, right? And if Q1 minus Q2 is greater than Q3 minus Q2, then it tends to be negative skew. So it as a part of the rule. But we just have to see the box plot and see the regions, all the regions, and try to see that which region has, so each region will consist of 25% of the data only, but we have to see that which is more scattered data and which are the regions which are compact, to see the skewness in the distribution of the data. So hope you have understood boxplot and how to judge skewness in different cases and how to determine the outliers using boxplot, right? So if you like the video, the explanation and the content, please subscribe my channel and like the video. Keep shining and thank you.